Oi, minasan, konnichiwa. So in this live stream discussion, we'll now go to the next strength limit state, which is about rupture. So when we are going to apply rupture, definitely we're going to use the corresponding area that is effective net area. Okay, so let us first allow somebody to confirm to us the sound check. So please confirm the sound check. Okay. Shout out kay Josh. According to him, clear po sir. Okay. Okay, let's proceed with our discussion. So rupture on effective net area. So we have net area, we have effective net area or effective area. Okay, so don't be confused about the two. So we'll discuss it. We already done so many things about this, but let us proceed. If holes are included in the cross-section, less area resists the tension force. Okay? So because there are holes present on the cross-sectional area, in some part, in the specific parts, those area would be the weakest region. Okay? So we will focus our attention on the weakest region because that is where we can expect greater risk of failure. Bolt holes are larger than the bolt diameter. This is number 2 principle. We already know that we have to add 1 over 16 up to 1 over 8. If we are talking of most common size of bolt. Okay? In addition, processes of punching holes can damage the steel around the perimeter. That's why we are doing this. This is the actual reason. So it is being presented by the code because there is no mathematics into it. Another thing wherein you can research about it. If you can find another practical process that may give us lesser amount of clearance from the diameter of the bolt. Okay, so it is much better because the greater the amount of net area, the greater is its resistance capacity to failure. Okay, so design typically uses average stress value. So average stress. This assumption relies on inherent ductility of steel. So average steel values. For example, you have here on your screen. So a connection. So wherein the connection is experiencing tension. Tensile force, Pn, nominal force Pn. Okay, so if there are, for example, 6 bolts, so these 6 bolts will what? Will have acting equally against the applied tension. So meaning Pn over 6, right? So Pn over 6. For each of the bolt holes. Okay? Okay? Next, uh, as you can see, initial stresses will typically include stress concentrations due to higher strains at this location. Take note of the red portions. Okay? The red portions are actually the net area left. Okay? That is the net area retained after the holes were punched or will drilled. Okay? O the net area. Okay? Red portions. However, take a look, not only the red portion, the shape of the red portion. The shape of the red portion, that is the stress being felt by this member. Okay? Stress. Okay? Okay, what do you mean by initial stresses will include? So, there are stress concentration, meaning from our assumption of average stress values, so we are actually assuming that in each and every location, they have equal values. We call average, but in reality, there is a what? Initial stresses that looks like this. Okay. Next, highest strain locations yield. Okay. Then elongate along plastic plateau while adjacent stresses increase with additional strain. Okay. So, let's proceed. Eventually, at the very high strains, the ductility of steel results in full yielding of the cross-section. Take note, from initial to the full yielding. So the full yielding, you can now see that there are the same stresses. While if you look at the initial, intermediate, there is no equal amount of stress being felt by the member. Here, now, we have an equal amount of stresses. Take a look. Behind the holes, take a look behind the holes. There is no stress felt by this member. Okay? Therefore, average stresses are typically used in design. Okay? So, when we are on the full capacity of the material. So, since we are looking at the full capacity of the material, although we know that the material may not experience the same amount of stresses, so typically we are using that assumption. Okay? We are assuming that even though so similarly, bolts and surrounding material will yield prior to rupture due to inherent ductility of steel. Okay? So, that is the case, no? Due to inherent ductility. Okay? We can expect that. Okay? So, bolts and surrounding material. Okay? So now, let us talk about the rupture on effective area in much greater details. Okay? So, we have shear lag affects members. Yes. Okay. What we just presented is what we call shear lag. Okay? What we have presented, the concept that we have just presented is what we call shear lag. Okay? Meaning, at different stages after application of the load, different experiences suffered by the material. Okay? So, shear lag. Only a portion of the cross-section is connected. Connections does not have sufficient length. Okay. The plate will fail in the line with the highest force. Okay. Okay. For similar number of bolts in each line. So, each bolt line shows transfers 1/3 of the total force. So, what do we mean by bolt line? So, this is what we mean by bolt line. 1, 2, 3. So, there are 3 bolt lines. That is what we mean by bolt line. So, vertical. This vertical. Okay? So, this is what we mean by bolt lines. So, net area reduced by whole area. This is what we are actually doing. We have examples using this. Okay? So, if you cut off this portion, okay, if you cut off this portion, the total tensile force is actually being resisted by total resistance, which is equal also to PL, okay, of the material. That is for the first, this part, and after that part we have this part. So this part is 2/3 because the holes are also exerting 1/6, 1/6. There are 2 of them, so 1/3. So this part exerts 2/3. Take note. Very important. So when we are going to solve this, which bolt line suffers the greatest amount of stress? They are not the same. Okay? If you can compare here, the gross area here will feel all of the tensile load, while up here only the remaining 2/3 of the tensile load will be felt by this part of the material, because bolts will take care of the 1/3. Okay? 1/3 meaning the line number 1, the bolt line number 1. Okay? Bolt line number 1 take care of the 1/3. Okay? And then after, listen, after the bolt line number 2, only 1/3 is being filled by this section. If you cut this element here, so remember, we cut the element here, we cut the element here, now we cut the element here. Okay? The remaining load is only 1/3 of the tensile load. Only 1/3 of the tensile load, because there are already 4 bolts that take care of the 2/3 of the load. That's why only 1/3 is left. Okay? And therefore, you can expect that after the bolt line number 3, there is no tension load being resisted by the material. Okay? So therefore, the most critical cross-section of the material is the first or before the section before the first bolt line. Do we follow? Do we follow? So the tension before the first bolt line looks like this. It is equal to the load. But after some time, it becomes 0. Okay? So therefore, if I ask you, at which region is the most susceptible to failure? Okay? Which region is the most susceptible to failure? Okay? Which one is the most susceptible? The region which is near to the load. So this is near to the load. If you cut off, that is the region which will matter most. We have to focus on. Okay? Okay. Next slide. The plate will fail in the line with the highest force. Again, same concept. We have bolt 1, bolt 2, bolt line 1, bolt line 2, bolt line 3 that resist piece of bend in the plate. We are talking of the plate. Okay, 2/3 PN in the plate and 1/3 PN in the plate. Okay, and actually after that 0. So there are 4 in between regions. Okay, in between what? In between bolt lines. Okay, it's very clear. It's very clear to us. Consider how this is affected by the strain condition. Consider length is equal to 1 inch diameter holes. Okay, 1 inch. Let us take a look. Okay, so if we have that, the same still stress strain diagram, same. Again, the same characteristic. This is corresponding to strain of 0.001 to 0.002. This is corresponding to 0.01 to 0.03. This corresponds to 0.1 to 0.2. This corresponds to 0.2 to 0.3. And you can memorize those values. Okay? Okay. So again, now instead of the average, we are actually using 0.0017. Take note, we are using 0.0017. That corresponds to the maximum yield point. So times 1 inch, that is 0.0017 inch. Very small, very small. It's a very small change in length. It's a very small change, almost negligible. But on the strain hardening, okay, the onset of strain hardening, so we have 0.02 becomes larger. What about on ultimate? 0.15 inches, and then we have 0.25 on the rupture. So this is the summary. If we have what original length is 1 inch hole diameter, we have the rupture. Okay, so we are looking at rupture on effective material compared to the summary when we are considering about 100 inches, because we are looking at the gross area, the yield on gross area. So this failure at net area can achieve ultimate strength so long as ductility is available. So this is up to the ultimate point. Okay? So remember, okay, there is no rupture up to that point. So after ultimate point, now the rupture comes in. So from the yield point to the rupture, there is a very lengthy amount of time before the element would actually broken down into pieces or smaller pieces. Okay? For a plate with a typical bolt pattern, the rupture plane is shown. Yield on the gross area, okay, yield on gross area would occur along the length of the member, throughout the total length of the member. That is what we are talking about if we are looking at the yield limit state. Okay, strength limit states on yield. Okay. Both failure modes depend on cross-sectional areas. They are depending upon the cross-sectional areas, but yield is gross area and along the total length. Along the length of the member. However, the rupture that is concentrated on the rupture failure across section at lead bolts. Usually, the lead bolt suffers the most. So, the leading bolts, meaning the bolt line number 1, is the most susceptible to failure. Okay? Bolt line number 1. Yield failure or elongation occurs along the length of the member. But when we are talking of rupture, that is the difference between rupture and yield. Okay. What if holes are not in line perpendicular to the load? So, staggered. So, this is what we mean by staggered load. Holes need to include additional length per area of failure plane due to non-perpendicular path. So, there is an additional, that's why we are adding, we have plus, we are going to use the plus sign. So, we are subtracting the whole, but we are going to add because there is what? An additional length per area of failure plane due to this diagonal path. Okay, so this is staggered hold. Take note, we have gauge and we have lateral length. Okay. Additional strength depends on geometric length, increase, combination of tension and shear stresses. So we can also compute shear and tension combined. So combined effect makes a direct calculation difficult. So that would be subject to next particular discussion. We have not yet come to that. Again, boundary of force transfer into the plane from each bolt. So look at the possibilities of force transfer. Force transfer that would be felt by the material, molecules, particles. Okay? And will be resisted by the crystal structure of the material. Okay? So, as the force is transferred from each bolt, it spreads through the tension member. So, that looks like this. So, the stress is spreading like this, going. So, the stress being felt by the bolt, and then transferred to the bolt hole, and then bolt hole to this material is spreading outward, no? Spreading, okay, to the tension. It's sometimes called the flow of forces. The forces flow like this. Okay? Note that the forces from the left 4 volts up on the full cross section at the failure plane, bolt line nearest load application. Okay? So this 4 is 4 on the left compared to the first line. So the first line is the most susceptible. That could be the weakest portion. Okay? Take note of that. That is the weakest portion. Take a look. Take a look. Okay. That is the stress being transferred to the material because of this tension force. So at the rupture plane, okay, the right bolts, this one, okay, forces have not engaged the interplate. Okay, so interplate, this interplate from the edge to the edge at the bottom, top to the bottom edge. So if the plate is wider, okay, compared to if the plate is thin, meaning the dimension from this point to this point. If you measure this point to this point, this is thinner plate compared to this one. Okay? Okay, compare. Okay? So there is what? The angle distributing the flow of force. Okay? So there is an angle here. There is an angle. I do not know what is the angle, so maybe we can find out from the code what is the actual angle. Or we do not know if that angle is even important or not. Okay. So rupture plane is the bolt line number 1. Okay. However, even in bolt line number 1, okay, there is no stress above this line. There's no stress. There's no stress below this line. So this stress is concentrated from this point to that point. That is the concentration of the stress. And that stress concentration is actually equal to this. When in fact, we are assuming average. Take a look. We are assuming average. So that's how different is the actual to the theory, to the so to our model. So we are modeling average, but the actual is not. Portion of members carrying no tension. So these are the portion with no tension. So rupture plane is this one, the rupture plane. So only this effective length suffers so much. Only that effective length suffers so much. Okay? Not the whole section. So meaning there are applications wherein net area is not equal to effective area or effective net area. There are application wherein net area is equal to effective net area. Okay, that is one clear view from this discussion. Take note, 30 degrees. 30 degrees. Okay, we have this the spread of the stress. They are spreading at 30 degrees on both sides. Okay, so this is what we call the Whitmore section. With more section. LW meaning width of with more section. So, take note, with more section. That is actually the effective length of rupture plane. Okay? Okay, rupture on net area, so shear lag. Shear lag therefore accounts for distance required for stresses to distribute from connectors into full cross-section. Okay, so there must be a distance wherein the stress will totally distribute throughout the whole section. Okay? Largest influence when only a portion of the cross-section is connected and connection does not have sufficient length. So if the connection does not have sufficient length, then the influence is the largest. Okay? Also, when the portion of the cross-section is connected. Okay? When only a portion. Now, so therefore, because of this theory, we have now the concept of shear lag. Okay? Wherein we can define AE, effective net area, AN, net area, and AE is not always equal to AN due to shear lag. So, for example, we have angle bar and we have the bolt holes like this. Okay? So, we have L1, line 1, line 2, line 3. So, length of connection. This is what we mean by length of connection. Okay? And rupture plane. Where is the rupture plane? The section with the critical section, it is the section nearest to the tensile load. Okay? It's the nearest. Or the leading holes, the leading bolt line. The leading bolt line. That is the rupture line. And distribution of forces through the section. Take a look. Okay, so there is no stress above this black line. There is no section from this point. So the stress is only from this point going here. Okay. So that is the only. The gray portion experience stress, while the orange portion does not. And because of that, area not effective in tension due to shear lag. So, you are looking at the cross-sectional area. This is the cross-sectional area. This is the cross-sectional area. At the what do we call that line? That is what we call rupture plane. So at rupture plane, we have this, and only the black portion experiences the stress. The black portion is what we call effective net area. These are in tension. Tensile force. Okay? The white portion, this white is the whole projection, and this white is the section wherein we do not experience stress. Okay? This means shear lag less influential when L is long. Okay? L What do you mean by L? From this to this, that is L. Or if outstanding leg has minimal area or eccentricity. So L, take note, length of connection. L means length of connection. Okay? So when L is long, so shear lag becomes less influential. Meaning, if L is long, immediately the whole, the total net area will become effective net area if L is long enough. Okay? Okay? Those are the important concept from this discussion. Let us get the break and come back. So we'll have a break. And come back from this discussion. Also, as you can notice, Mr. Bren Pasqua posted what is this? Online student evaluation, faculty performance midterm. So we will have break time because we actually have the break time, and also you have to fill that form. Okay, so I will just post a message if we are now going to start or resume our class. So again, I will take a look at the comment box. If there are questions, any question? So there is no question from 22 attendance. There are 22 of us, including me. So out of 46 students, so we have 20. Okay, thank you. There's no question, so I'll see you on the next live stream. Again, this is Dr. AP, preaching engineering for nation building.